Hi, I'm an old guy and I do maths. And I thought we'd have a look today at polynomial remainders and why we treat them as we do. So let's find ourselves a polynomial remainder. We'll just invent one. Let's say we got 2 over 2x plus 3, something like that. Okay, so why, when we do a long division of a polynomial, such as you saw in the header, so we've divided in the header, we divided a cubic by a linear factor and we got a quadratic, and on the end of that quadratic there was an expression like this. It wasn't this, I can't remember what it was, but it looked like that. Why do we do that? Well, the answer is, I was going to say it's buried in very simple maths. It's not buried. It's pretty obvious. And I'm going to show you what I mean just using numbers. Because you have to remember that what algebra is it's in many ways a test of your knowledge of the rules of mathematics. And what happens is simply numbers get replaced with letters, or letters stand in for numbers that we don't know. But the rules of algebra are the rules of mathematics. So if you can do things with numbers, you can do them with letters. So let's have a look at what we've got here. So 11 divided by 3. Well, we know that 3 goes into 11 3 times, and that gives us 9, and we get a remainder of 2. And so it is perfectly reasonable, although slightly unhelpful, to say that 11 divided by 3 is 3 with a remainder of 2. Now, how can we make this more informative and more accurate? Well, there's another way, of course, and I'll just set this up. Okay, so we're at this point already. Now, what we do now is, because 3 won't go into 2, we'll pretend that this is 20, it's 2.0. 3 goes into 2.0.6 times, gives us 1.8. Subtract that, we get 0.2. Pop a 0 on the end of that, and you can see where this is going. It's going to be an endless recurring decimal. The decimal is slightly unhelpful. We can convert that, of course, to 3 2/3. But we can go straight to this. Let me show you. And this is where what you see up here comes into play. So 3, 11, 3, oh sorry, the 9 should go there, the line should go there, that's 2. So just ignore that line. So 3 goes into 11 3 times, that gives us 9, subtract that, gives us 2. And so 3 goes into 11 3 times, plus the remainder 2 divided by 3, or 3 2/3. And what you just saw there is what you see here. It is a perfectly accurate way of describing what a polynomial divided by another polynomial equals when there is a remainder. I should remind you, this really only arises as a question when it comes to remainders. Anyway, this reason here is why you see remainders often expressed in this form as part of the result when you divide one polynomial by another. I hope you found this helpful. If you did, please like and subscribe, and I'll see you next time. Bye.